Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Apa khabar kita? Semua sihat?
Sehat, sir.
Okay, good. Okay. Sebelum kita start, ada apa-apa? Any question, anything from last class or or from the material that we have learned so far? Any question? Any comment? Anything? Tak ada. Okay. Ada bagus. Okay. So today what we'll do? We will continue with the derivative. I think we already learned about the concept. I think the concept we have discussed now. So we know that what is the idea of derivative. So today I'm going to cover 9.4, 9.5, 9.6. We will deal with the rules of derivative. How to get the derivative. It's easy, because there are rules, there are formulas. So we'll learn the formula in order for us to get the derivative of a function. So that wouldn't be a problem. So let's look at the rules of derivative, and we will start with 9.4. So first rule. So it's not difficult, right? Like I said earlier, because there are rules. Now the rules are rule number 1. This is called the power rule. If you have a function of the form x equal to n, f of x equal to x to the power of n, where n is the real number, then what is the derivative of the function? So f prime or y prime is equal to, okay, I want you to look at the screen, look at the f prime, and see how we get the derivative. Okay. Go look at it, and then, yeah.
What we see is the Zoom tab.
Huh? Oh, you don't see the PowerPoint screen, the PowerPoint?
Not yet, sir.
Yes, sir.
Apa sih? Wait, let me see. I already shared the screen. What about this? Can you see the notes?
Okay, sir. Now, okay.
You see the notes? My note.
Now, yes, sir.
Huh? Okay. Now the PowerPoint note. Can you see that?
Yes, sir.
All right.
Yes,
So
sir.
if you look at this example here, not this example, this is what you call the power rule. All right. So rule number 1 is the power rule. So 1, I write down. Okay, and then we go back to the rule, the formula. So that is the power rule. Okay, you have a simple function, x to the power of n, where n is the real number. What is the derivative? So you look at the screen, you write it down, how you get the derivative. Okay, somebody describe for me. How do you get that derivative?
The x we multiply with n, then n with -1.
So what you do, you bring down the power, okay? You bring down the power n, and then you multiply by x, and the power reduced by 1. So you have n times x to the power of n minus 1. So that is what you call the power rule. So if you just use y prime, so we can use y prime or f prime. So y prime sometimes easy to write. Y prime is equal to what? N multiplied by x, you reduce the power by n. So now n is a real number, okay? Real number, that means it can be negative, positive, decimal point, or whatever, all right? Example, if I have y equal to x to the power of 12, then what is y prime? You bring down the power, so it becomes 12 multiplied by x, all right? and then reduce the power by 1. So that's 11. Or example number 2, I got y equal to x negative 4.7. All right. So what is y prime? Again, here you bring down the power, okay, and multiply by x, reduce the power by 1, so that becomes what? Negative 5.7. Okay, so this is the power rule, very simple. So what you need to remember is just remember the rule, okay? And the derivative is a function, and that function derivative will give us this slope, okay? The slope of the function at any point. Okay, what is that sound? Can somebody that make the sound? Can you mute your what do you call it? Your mic. Ada bunyi tu, kacau tu. Okay, all right. I give you another example. This one I want to relate to the derivative. Okay, so let's say f equal to f of x equal to x squared. Now x squared, as you know, if you don't know, that's okay. I give you the x squared. The function will look like this, the curve. So that is y equal to x squared. Okay, now how do you find the slope of this curve? So in order to get the slope, you do the derivative, and you know the y prime equal to f prime of x equal to what? By the power rule. What is the derivative of the function? X squared. Derivative, what is it?
2x.
2x.
2x, okay, very easy. So here, the derivative can give you the slope of the curve at any x, at any point. Example, let's say at x equal to 1. What is the slope? So in order for you to find the slope, okay, find the slope, that means I use the derivative. So y prime equal to what? Equal to 2 times 1, that is 2. So the slope at x equal to 1 is 2. Of course, you can find the value of y, right? So let us draw the graph, the slope. So x equal to 1, let's say somewhere here, all right? And then the value of the y, of course, x squared, so that will be also 1. So y equal to 1, that's the point. So the slope, as we know, the slope, how do you get the slope from the derivative? I know it's equal to 2, and it will be the slope of the straight line just tangent to the curve at 1. So the slope here is equal to 2. Okay, and that is given by what? By y prime. Okay, or dy dx. Now, if I want to find the slope at x equal to, say, 5, what is the value of y prime?
10.
You got 2 times 5, that is equal to 10. So the slope at x equal to 5 is 10. So you got 5 here, and the value of y, okay, you got 5, there will be over there. The value of y is what? The value of y is 25, 5 squared. So that will be 25, and the slope is equal to 10. So how do you get the slope? The slope of the straight line tangent to the curve at that point. So here m equals 10. Okay, now let's try another point. Say x equal to negative 8. Okay, negative 8, oh no, negative 8. Negative 8, I think it's too far. So let's say negative 4. Okay, when x equal to negative 4, what is the value of y? Value of y, value of the function at x equal to negative 4, what is it?
Negative 8.
No, not the derivative, the value of the y, the value of the function at x equal to 16. So you have negative 4 somewhere here, all right? And the value of the y is 16. The value of the y, you have to use this function, huh? Okay? And then you want to find the slope. What is the slope at x equal to -4? I take y prime, okay? Or f prime of x, that will be equal to 2 times -4, that will be equal to -16. So the slope is -16. And as you can see, what is it? It's the slope of the straight line, tangent to the curve at x equal to -4. The value here is equal to what? -16. So as you can see here, the slope, the function is nonlinear. What can you say about the slope? Yes.
Isn't the derivative -8?
Negative? Yeah, -8. Okay, thank you. Yeah, -8. 2 times 4, -8. So that should be -8. Okay, so here -8, not -16. Okay, now what can you say about the slope of this curve? And most of the curve that we are looking at will be non-linear. Okay, so what can you say about this slope at any of the points? By these examples that we have, of course, you can find the slope at any point you like. Okay, what can you say about the slope here? What can you say about the slope? I got 3 points. No, slope is 2, 10, and then -8. Okay, what can you say about the slope at any of the points here? I can get one more slope over there.
Different.
The slopes are different. Okay, so for the nonlinear function, the slopes are different. You can have for the same curve, the slope is negative and the slope is positive. Correct? And the slope can also be 0. Okay, now slope equal to 0 where? Where is the point the slope is 0?
0, 0.
0, 0. At point here, the slope is 0. So you see the slope is equal to 0. Slope can be positive, slope can be negative. Okay, all right. So that is the idea where we use the derivative to get the slope. Now, this can be applicable to any function. So this is one example because this kind of function is very, 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 very common. Okay, all right. Any question? All right. So that is the power rule. Now, rule number 2 is the constant power, the constant rule. And of course, there are a few examples in the book. I already give you a few examples. So example, you go home, you buat lah. Okay. The next rule would be the constant rule. Now, constant rule is very simple. You have a function y, which is just equal to c. And c is the constant, right? So example, y equal to f of x, I use f of x now, f is equal to say 101. That's a constant. Now, what is the f prime of x or y prime? So the rule is the following. So if you have a constant, constant rule. Okay, constant rule. Don't worry about the limit. Okay, we use just the rule at the bottom of the page. Now, what is the derivative of a constant?
0.
0. So if it is constant, derivative is 0. So don't worry about the value of the constant. It can be f of x equal to 10, and that will be equal to 0. Okay, so that would be the constant rule. Now, next rule is, this is what you call the coefficient rule. You have a function, something like this. I have, say, y equal to 13x to the power of -5. So I have a constant here, or we call coefficient multiplied by that x. So what is the rule? Okay, the rule is that we call it coefficient rule. So generally you call it y equal to c multiplied by u. You know that u is some function of x or some terms in x, just x. That is x. I mean, just x or x raised to a certain power. So what is the rule? Okay, you just read the rule and write it down. What is the rule? Okay, you describe the rule. How is the derivative being determined?
The constant multiply the derivative of
So it's just the constant multiplied by the derivative. So the constant will just follow the derivative. Okay, the constant will just follow the derivative. So don't worry about the constant. Okay, just keep the constant as it is and multiply by the derivative of the term in x. So that would be the rule. So if you look at the rule there, okay, the constant will just follow the derivative. So I show you again. So make sure you write it down. Okay, because I'm not going to write it down. I just show you. And then we will consider an example. So you have c multiplied by u. So you don't have, you know, for this thing here, we don't have to write u as a function of x, just write u. So that means, you know, y is equal to c times u. And we know the u is some terms in x. So for example, here, that u is equal to x to the power of -5. Okay, so you don't have to write u as the function of x because we know u is some terms in x. So what is the derivative? Okay, I'll show you again. I write it down. So that will be equal to what? Y prime or f prime is equal to c times u prime. So don't worry about the constant. The constant will just follow the derivative. You just differentiate the terms in x, which is u. So you got c multiplied by u prime. Okay. Okay. So example, I have here y equal to 13x to the power of -5. So don't worry about that 13. The 13 will just follow the derivative. And here you have x to the power of -5. You just differentiate the x to the power of -5, which we know by using the power rule. All right. So what is it equal to? So 13 just follow the derivative. And then I have -5. Okay, so it's negative, you put in bracket lah. Okay. And then x reduce the power by 1, that becomes -. Okay. So that would be the coefficient rule. Okay, another example, let's say y equal to 25, okay, x multiplied by x to the power of 1/3. Okay, now get the derivative. So the 25 will just follow the derivative of x to the power of 1/3. Okay, what do you get?
1/3x. 1/3x power of -2/3.
25, where does it go? 25.
25.
The constant.
25 times
Ah,
1/3.
Okay, so the 25 will just go with the derivative. All right, so 25, okay, multiplied by, you bring down the power, 1/3 times x, 1/3 minus 1, that will be -2/3. Okay, so that is the coefficient rule. Okay, any question?
No.
All right, so next rule would be, okay, this is the coefficient rule. Next rule would be, okay, there are a few examples. Probably we do one of this. Okay, just look at C. You have here 5 divided by square root of Q. Now, square root of Q, what is it? Square root, what is the power of square root?
1/2.
1/2.
It's not 2, okay? It's 1/2. So you have to write 5 over Q to the power of half. So for that example, you have P equal to 5 multiplied by Q to the power. No, before you do that, let us maintain the fraction. Q to the power of half. Okay, so now you have to bring it up. So it will be 5q to the power of negative half. Okay, so from here you get the p prime. Okay, so you can do it. Okay, so we'll finish up. All right, now the next rule would be the difference and sum rule. So difference and sum rule, or sum and difference rule, would be you have two or more terms in X which are added or subtracted. And how do you differentiate that? The rule, that's what you call the sum rule if they are added, and if they are subtracted, you call it difference rule. So let's consider first the sum rule. If there are two terms, f of x or y equal to u plus v, then what is the derivative? Or how do you take the derivative of the function? Okay.
One by one.
How do you differentiate? You differentiate u, and then you just differentiate v. So you have to differentiate each of the term, okay, and maintain the sign, whether it is here is plus sign because it's sum. All right. So you just differentiate each of the terms and then maintain the addition sign. So if you have u plus v, then it becomes u prime plus v prime. All right. So example, okay, this example is not very good. I'll give you another example. So example, let's say I have y equal to 5x to the power of 11 plus negative 10, okay, negative 10, x to the power of negative 7.6. So what you do here, this is a sum sign, okay, sum, because you have a negative positive sign there, all right? So what you do, you just differentiate u prime, and then you differentiate v prime, maintain the sign, all right? So that will be the sum sign. So what do I get? I get 5 multiplied by 11, x reduce the power by 1, so that becomes 10 plus, okay, negative 10 multiplied by negative 7.6 times x reduce the power by 1, so that what does it become? It becomes negative 8.6. So that is our derivative. And of course, you can multiply that out now. Okay. All right. So that is sum rule. Okay. Now go to the book. Go to 9.4. I think probably we can do 1 or 2 questions in 9.4. Go to 9.4 in the book. I would like to probably now this thing here. You can also apply if you have more than 2 terms. Let's say you have more than 2 terms. All right, you have 3 terms. Example, you have 4. So that also apply. Okay, you just differentiate each term. So let's look at one question, if there is any, where we have, more than 2 terms. Let's see. Otherwise, we will just generate one. Okay, go to 9.4. 9.4, let's look at one question where we have, okay, yeah, you look at question 9.4, 9.4, question number 15. Okay, question number 15, you have 3 terms. Yeah? So you have 3 terms, don't worry about the x equal to 2. We just want to find the derivative. So what is the derivative? There are 3 terms. Again, you apply the rule. You just differentiate each of the term. Okay? So what does it become? Okay, get the derivative. Number 15. So what is y prime?
7. 7 to x.
7 2x, 7 times 2. So that becomes 14x. Okay, that's the first term. And then differentiate the second term. Second term is 2x. What is the
2.
derivative? 2. And then you have a constant 1. So that
0.
becomes 0. So the 0 tak payah tulis. Okay, this one is right. So you have, the rule is what? The rule is you have to differentiate each of the term. Okay, sometimes it can be more than 2, even though the rule say u plus v, but it is applicable for more than 2 terms. Okay, all right. Now that rule will also hold if you have a minus sign instead of a positive sign. So we have, by the same approach, you call it difference rule. So instead of having u plus v, what do you have? You have u minus v. So again, we just differentiate each of the term, maintaining the sign. So you got u prime minus v prime. Okay, so the rule are similar in terms of how you get the derivative. The only difference will be what? The sign. Okay, so that is difference rule. So you have f of x equal to u minus v, f prime equal to u prime minus v prime. So example would be, I give you an example. Let's say we have y equal to, so example, y equal to, it's equal to 5, you know, because 5 now. Y equal to 11x to the power of 3.4 or 3.7 minus 2x to the power of 1/4. Okay, so you have here a negative sign. So we apply the difference rule. Take the derivative of each of the term, maintaining the negative sign. So what is y prime? Y prime is equal to 11 multiplied by 3.7, reduce the power by 1, so that becomes what? 2.7. And then keep the sign. And then you differentiate the next term. What will be? What will be? So 2 times 1/4 x. Reduce the power by 1, that becomes what? Negative 3/4. Okay, so that is difference rule. All right, now go back to the question, to the book. We do another question. Okay, so I want you to do number 14. Now, question number 14, you have combination. Okay, you have many terms over there. You have combination, plus minus, plus minus. So don't worry about the sign, just differentiate each of the term, keeping the signs. Okay, now go ahead, do that number 14. Okay, you got it? Okay, the first person who got it, just say, I got it. You got it. Okay, anybody who has done it?
I got it, sir.
Okay, what is the derivative?
The derivative is 12 multiplied by 20.
Okay, 12 times 20, correct? And then the x raised to the power of reduced by 1, that becomes what?
Become 19.
Okay, 19. Okay, that's the first term. Now, second one, plus. Okay, don't worry, don't worry about the sign, just maintain the sign. So plus, okay, second term.
8
Okay.
multiplied
8 times 10, x to the power of
9.
9. And then you have a minus sign, so negative. Minus 2, okay.
Negative 2 times 7.
Negative 2 times 7. X, okay, x to the power of what?
6.
6 plus one more term.
17.
17, okay? So that's it. The 9 will be 0, okay? So that is the y prime. So don't worry about the number of terms, the sum and the difference rule. You just take the derivative of each of the terms, keeping the sign, all right? Keeping the sign. So of course you don't have to simplify, but if you want to simplify, you just simplify the, let's say, the multiplication of the constant. So 12 times 20. So maybe another step, you write down, multiply this. But if you do it up to that point where we just describe it just now, that will be fine. Okay, all right. So for 9.4, I'll give you a few questions for your practice. We are doing 14, so that's good. So do number 7 to 14. This is 9.4. Now that is on the combination, all right? Combination of the power rule and also the sum and difference rule. And then you do number 23 to 26. I think I give enough questions to practice. So here you have the coefficient rule, power rule, sum, difference rule, and constant rule. So I think there will be enough. If you want to do more, you're welcome. You can do more. All right. Okay. So that is 9.4. So we are done. Now the application we will do afterwards. All right. After I finish 9.4, 9.5, and then 9.7, I think. Oh no, now 9.7 to the application. We will do the derivative. No, the application of the derivative. So that will also include 9.9. So the application will come back afterwards. So that's 9.4. Now 9.5, you have a different set of rules, which are called the product rule. Okay, the product rule and the quotient rule. So here we have, instead of the terms added to each other, you have multiplicative terms. That means there are terms of x that will be multiplied by another term. Or you have a product rule. All right. So product rule is something like this. You have f of x will be equal to u, okay, and that one term of x. And then you have another term in x, which is v. So u times v. Now, how do you multiply? How do we differentiate that rule, that kind of function? Example would be, okay, I got to create another book. This thing here, they have only maximum of 100 pages. So after 100, we have to open up a new one. So example will be like this. We have y equal to, say, x cubed minus 2x to the power of 4.7, okay, multiplied by 5x to the power of 15 plus whatever, plus x to the power of negative half. So you see here you have multiplicative terms. So you let the first term be u, the second term v. So you have u times v. So that is the rule about. So you go back to the rule, you have u times v. So how do we differentiate the function? Okay, I want you to write down and describe how do you differentiate. You don't have to write u as u of x, okay? Just write u. times v. And we know the u is some function of x. Okay, so how do you do the derivative?
U v prime plus v u prime.
U v prime u v prime plus v u prime. In other words, you differentiate one term multiplied by the other. Plus, okay, I differentiate the other term plus the first term. Okay, so normally I prefer to write it this way. So I have y equal to u times v. Y prime is equal to what? U prime v plus v prime u. In other words, I differentiate u times v plus I differentiate v times u. But it's the same as what you have here in the slide. U multiplied by v prime. And then you add to what? V times u prime. So it depends on which way is more convenient to you. I prefer it the way I write it down because I do it in order. U times v. So I differentiate u first, but then v plus I differentiate the second term v multiplied by u. Correct? So I'm more convenient with this one. So now, given this example, you apply the rule. Okay? So in order to do that, suppose that is the example. So first that we need to let u be equal to the first term. And then you let v be the second term because it's you have u times v. Okay. Now what you need next is that I need u prime. So we find u prime right away. So what is it? It's 3x squared minus 2 times 4.7. 2 times 4.7, you can multiply that out. All right, 4.7 x to the power of, reduce the power by 1, so you have 3.7. And then v prime is equal to 5 times 15. You can get it. 5 times 15, x to the power of 14. All right, minus, because it's a negative half. So you can I can put the plus sign first. You got negative half. All right, x to the power of 1/2 minus 1, so that becomes negative 3/2. So maybe what we can do here is, instead of having 2 times 4.7, because very easy to multiply out. So you do that multiplication. And of course here the sign make it simpler. So let's do that. So what do you get? You got 6x minus 2 times 4.7. Anybody? 9.4, right?
Yes.
9.4 x to the power of 3.7. And then v prime, you have 15 times 5, that will be equal to 75 now. 75 x to the power of 14 minus half x to the power of negative 3/2. So I got everything. So that we can apply the rule to get the derivative. Betul? Huh? Any mistake?
U derivative.
The u prime first, sir.
Huh?
Why is it become 6x?
Oh yeah, you're right. I multiply 3 with 2, which is wrong. So it shouldn't be 6x. Should be 3x squared. Okay, thank you. So this one should be 3x squared. Okay, I don't know how I get 6. Maybe I multiply 3 and 2. Okay, so you got that thing? So now what you do here, apply the rule. Okay, so the derivative will be y prime equal to, you plug in the things. All right, u prime 3x squared minus 9.4x to the power of 3.7. 3.7, I put the bracket. Okay, 3.7. Okay, that's u prime multiplied to the v. So you got 5x to the power of 15 plus x to the power of negative a half. Okay, now plus v prime. V prime is 75 x to the power of 14 minus a half x to the power of negative 3/2. Okay, multiply 2. So what I do, I take out Manila, because I am out of space. Multiplied by v, which is x cubed minus 2x 4.7. Okay, so that's the thing. So now, in order for you to do the derivative, you have to let u be the first term, v the second term, and then find the u prime. Okay, get the u prime, get v prime, and then plug into the formula, plug into the rule. So u prime times v, or if you follow the book, it will be v times u prime. Okay, same thing, plus u v prime. Or if I follow the order of my rule, the same rule, u prime, which is 3x squared minus 9.4 multiplied by x to the power of 3.7, that's u prime multiplied by v. Okay, so I got that. Okay, any question? So that is product rule. So in order for you to give, I want to give you a practice. So let's consider an example. Another example. So another example would be this one. Okay, so I want you to do this example here. Do the part A. Okay, don't worry the part B. Part B, you can go home and do it later on. So you do part A, okay? You have u times v. So you let u be the first term, v the second term, get u prime, get v prime, plug into the formula. Okay, all right. And if you want to check, you check the answer given on at the bottom. Okay, I give you 2 minutes. Do it now. Okay, you got it? Now, what is u prime?
2x power of 3 plus 3x power of 4.
No, u prime.
Or 6x power of 2 plus 3.
6x power of 2 plus 3, so that's u prime. Okay, now you let v be equal to x squared plus 4. So what is v prime?
2x.
2x. Okay, so you find u prime, find v prime, and then put into the formula. All right, so formula is y prime is equal to u prime v plus v prime u. Okay, finish it up. You don't have to simplify. Okay, just do it up to the formula u prime times v plus v prime times u. If you want to simplify, you simplify at home. Okay, I think if you want to simplify, you just multiply the constant, which are easy to multiply. Other than that, we don't have to simplify. Okay, all right. Now I give you another 2 minutes. Okay, finish it up. So actually, you have the solution here. Okay. So I would like you just to finish up to this point. You don't have to multiply everything. Okay. So you don't have to worry about the second step and the third step. What I need is only the derivative, which immediately follow the rule up to here. Okay, we need only up to here. You don't have to simplify, because the most important part is we are able to use the rule to get the derivative. Okay, all right. So that is the product rule. And I give you some questions on the product rule, which is 9.5. Okay, for 9.5, I would like you to do some questions on the product rule. There are 1 to 4, all right, 7 to 8. So that's product rule. And then 11 to 7, it's on the quotient rule, which I will do now, okay? So the next rule will be the quotient rule. Now, quotient rule, you have division of two terms in X instead of multiplicative. Oh, no, instead of multiplication of two terms. So that's quotient rule. We have the following. We have f of x or y equal to u divided by v. So if I go back to that example, mana ada example ni? Ni example ni. So if I go back to this example, 2x cubed plus 3x plus 1 multiplied by x plus 4. Suppose benda tu jadi division. Okay, can anybody who has the audio, can you mute yourself? Because I am hearing some background sound, you know. So it's quite convenient. Okay, if you are on, if your audio is on, can you please mute it? Okay, you can on later on if you want to talk. Okay, because I heard some background sound. So now you look at the quotient rule. Example, okay, example of quotient rule is the following. You have a ratio of two terms in X. Now, if you have some function like this, I use again example number 1. I use example number 1. Suppose instead of you have multiplication, I have y equal to the 2x cubed plus 3x plus 1 divided by the other term, x squared plus 4. So now you have quotient rule. So what you have here is u divided by v. So you don't have to write u of x divided by v of x. Now, when you have division of two terms, what is the rule? The rule we use is the quotient rule. Okay, called the quotient rule, and this is how the rule works. So I want you to write down the formula. Okay, because if you don't write down the formula, it's more difficult to remember. If you write down the formula, every time you write down, the memory will be stronger. Okay, write it down. What is the formula? What is the rule? Okay, so what you do here is, there is a negative sign, all right? So I prefer u prime, you know, I prefer to say u prime first. So in other words, you have u prime multiplied by v minus v prime times u, everything divided by v squared, the square of v, the square of v. So if I have y equal to u over v, the derivative is y prime equal to u prime v minus v prime u. So this is negative sign, all right? It's not positive. Everything divided by v squared. So that is the quotient rule. If you go by the book, all right, they use v u prime, same thing. minus u v prime. And then everything divided by v squared. So again here, if you follow the rule, in other words, we need to have u prime, I need v prime, because that's the rule. Okay, so we have done this example. If you let u be the term in the top, so u be equal to 3x. Ini lain. Lain. I think I asked you to do it. I didn't do. You do it. So now I'm going to do the derivative. So you let u be equal to the numerator. So 2x cubed plus 3x plus 1. Now what is u prime? U prime is 6x to the power of 2 plus 3. And then I let v be equal to x squared plus 4. And v prime is equal to 2x. So apply the rule. So the derivative will be y prime is equal to what? U prime times v. So 6x to the power of 2 plus 3 multiplied by v, which is x squared plus 4. First term minus, okay? The derivative of the v, which is 2x, multiplied by u, which is 2x to the power of 3, plus 3x plus 1. Everything divided by v squared. Now, since this is very long, sometimes it's not convenient for us to draw a very long line. So you put another bracket, a big bracket, and then you just put macam tu je. Okay? You don't have to put a long line to divide the terms. So I just put that thing, and then I have v squared, which is x squared plus 4 divided to the power of 2. Okay. So that would be the quotient rule. Okay. All right. It is a little bit cramped here because I'm out of space. But if your page is long, you put the big bracket and then you put that division sign and then you put the denominator. I'm sorry. Either you can use the way I do it, or you can put the long division sign. But this bracket, okay, that bracket which I put here, okay, this is important to indicate that everything on the top is divided by x squared plus 4 to the power of 2. Now, suppose I didn't put that bracket here. Okay, I didn't put that bracket. And I use that small line to indicate division. So suppose it is like this. Contoh. I don't put the big line. I just put that small line and I divide by v squared. Now, how this is wrong? How is it wrong? If I don't put the big bracket, what does it mean? If you look at the terms here, what does it mean?
Only the last term is divided.
It's only the last term. The second term is divided by the denominator, not the first term. Okay? So if you want to do that without the big bracket, you have to do the big line. Okay? So if you draw the big line, you can, but because when I have this kind of thing, sometimes it's not convenient to draw the long line because it's very long. But depend on how you write it. So what I'm telling you, if you don't draw the big line, the long line, you put the bracket so that it will indicate we are dividing the numerator by the whole term. I mean by the by the x squared plus 4 to the power of 2. Okay, all right. So that is how that big bracket is important. Okay, all right. Any question? Okay, I'll give you another question to do. So go to 9.5. Do one question on the quotient rule. Okay, mana ada question eh? Wait, let me see if there are any questions. Okay, okay. Do question number 22. All right, so quotient rule, do number 22. So go to 9.5, question number 22. Now, don't worry about the question they ask you to find something else. What I want is get the derivative, just find y prime, okay, using the quotient. So number 22, please do it in 2 minutes. So remember the formula, okay? The formula is per given in the thing. You write down the formula, because if you write down the formula, you remember. If you don't write down the formula, maybe we can get mixed up. So when you do this derivative, all right, when you do this kind of derivative, write the rule first, okay? And then only you do the derivative. Okay, 2 minutes. Okay, you got it?
Yes.
Okay, good. So if you have u equal to let u equal to the top, so u is equal to what? X squared minus 4x. So what is u prime?
2x minus 4.
2x minus 4. And then you let v be the term at the bottom, x squared plus 2x. V prime is equal to what?
2x plus 2.
2x plus 2. So you got u prime, you got v prime. And then put into the formula, okay? Put into the rule to make sure we put it correctly. Now, you don't have to simplify, okay? Just put into the formula. If you want to simplify, you have 22 times 3. If multiplication of constants, then you can simplify. Other than that, you don't have to, okay? You don't have to, because our purpose is only to get the derivative. If other purpose are given, then probably we need to simplify lah. Okay, all right, good. So that is the quotient rule. So for the quotient rule, I already have given you some questions. And of course, the examples are given here, and these examples are coming from the book also. So I think we have enough. Now we move on to the next part. Next part is on the general power rule. Now it is built on the power rule, but more general, okay? More general, we call it the general power rule and the chain rule. So we will start with the general power rule, and then we come to the chain rule. So here I have a power rule. So that actually it's more general. So we call it the general power rule. So general power rule. The power rule that you have earlier, just power rule, okay? Y equal to x to the power of 5. So we apply the power rule, okay? But now we have the general power rule. It's more general. Now, what about if I have the following? I have 3x to the power of -5 plus 21x to the power of 3.7. 3.7 dah banyak kali dah. 3.7 apa saya ni? 3.7 ya. 8.1, 8.2. Okay, 8.2. Everything to the power of 11. You know, you have something like this. So that's where you need the general power rule. So here, I let u be equal to the terms and in the bracket. So you let u be equal to 3x to the power of -5 plus 21x to the power of 8.2. So I have u, y, in terms of u now, u to the power of x. So that u is not just a simple x, it's a terms in x, compound terms in x. It is made up of more than one term in x. All right? Or not the power of x, I'm sorry. It should be to the power of n. So let's look at the rule. Where is the rule? Rule here. So if you have y to the power y equal to the power u to the power of n, then what is the derivative? Okay, you read the derivative, write it down, and describe to me what is the rule about, and how does it different from the power rule that we did earlier.
Then multiply du dx.
The difference is that you multiply by what? You multiply by du dx. That means you have to differentiate u. Okay, the first term, the first part is the same. You bring down the power, multiplied by the term, reduce the power by 1. But that is not the end of the story. You have to multiply by what? U prime. So that rule is you have to multiply by u prime. So y prime is equal to n multiplied by u, you reduce the power by 1, and then multiplied by u prime. So that u prime is dy dx. Okay, so that u prime is dy dx. So sometimes, we don't need to write dy dx or du dx. So just say u prime or y prime. It's easier to write. So that is the general power rule. All right, that's the thing. So now we have the example already. Okay, the example is already given. So let's apply the rule. Okay, so let's apply the rule. So here I have y equal to everything here to the power of 11. So I let u be equal to the terms in the bracket. Then I have y in terms of like u to the power of n. Okay, so I need u prime. So what is u prime? U prime is equal to
-15.
-15.
X power of -6.
X power of -6. And then plus 21 times 8.2. Okay, give me the multiplication right away.
172.2.
172.2 times x 7.2. Okay. Okay, now put into the formula. All right. Okay, do it now. Okay, got it. Okay, Everybody got it? No. Anybody who got it, let me know. First person to get it, just say I got it. I will go. We go together.
I got it, sir.
Okay. Everybody got it? All right. Good. So now you apply the rule. Okay. You apply the rule. So the rule is n u to the power n minus 1 multiplied by u prime. So what you can do, okay, you can do the following in order for us to get familiar to the method. So the method or the derivative is y equal to n. N is what? N is 11.
11.
N is 11. So n is 11 multiplied by u. Okay, reduce the power by 1, so that becomes 10. And then you multiply by the derivative of the u, which is u prime. And that u prime is negative 15 x to the power of negative 6 plus 172.2 x to the power of 7.2. Now we have to put in the u. So I write another step to put into u the actual terms, all right? So 11 multiplied by 3 x to the power of negative 5 plus 21 x to the power of 8.2. Now the power is 10 and multiplied by, okay, the u prime, which we already have, 15 x negative 6 plus 172.2 x to the power of 7.2. So we can do this, all right? We can do this. You put the u, reduce the power by 1, and then you multiply by the u prime, okay? And then you put into the u the actual terms in x. So everything now in x. Okay, all right. So I want you to do one more. So go to the 9.6. I will find another question. Okay, one question that we can try to solve. 9.6. 9.6. Okay, 9.6. Let us find one question. Another question. The apa question rule tak banyak question. Dia banyak produk rule. I give you another example. So I already give you the. Did I give you question on 9.6? 9.6. Did I give you? Okay, 9.6. I would like you to do some of these questions. All right. 9.6, which is on the quotient rule, on the general power rule. General power rule and the chain rule. So 9.6, I would like you to do this question. Question number 5 up to number 9, and then 1 to 4. So 1 to 4 is the chain rule, okay? And then 5 to 9 is the general power rule. Okay? So, I asked you to do 5 to 9, right? So 5 to 9, we do one question. Do question number 8. Number 8, coba go. Okay, question number 8. So 9.6, I would like you to do question number 8. Now, to make things easy, they use k of x, right? So what you do, just use y. Okay, nanti tu tak payahlah k. You already have h of x, you know. For question number 7, to make our life easy, just to get the derivative, do everything, put y, you know, y equal to function of x. So rather than make use a, use y. Okay, so question number 8, please do it now. Now the constant will just follow the derivative. So don't worry about the constant, all right? We learned already the constant multiplied by some function of x. You don't worry about the constant will just follow the derivative. So just apply the power rule. Yeah. Okay, do number 8 now. Okay, got it?
Yes.
Okay, so you have gone through that question number 8, all right? So you know the rule, okay? The rule for this kind of function is y prime equal to n multiplied by u to the power of n minus 1 times u prime. So you let u be equal to the term, okay, which is 2x cubed. The term is in the bracket, 2x cubed minus x plus 6. And what is u prime? U prime is 6x squared. Is that right? 6x squared minus 1. So that is u prime. Now you put into the formula. Now the constant just follow the derivative. So y prime is equal to 5/7. Okay, you just write 5/7 over there, and then you do the derivative. So that would be what? That would be equal to, bring down the power, you have 14. Okay, 14 multiplied by u to the power of n minus 1. So I'll just write down the u, okay, times u to the power of n minus 1, which is what, 13? And then multiply to u prime, which is x squared, 6x squared, I'm sorry, minus 1. And then put that bracket. Okay, all right. So now you put in u, okay? You put in u as the terms in x. So put in the u here, okay, into, so everything now you got is in terms of x. So the constant 5/7 will just follow the derivative. Okay, all right. Everybody got like this? So if you don't get like this, check where you went wrong, okay? So you got check the u prime, and then make sure you get the u raised to the power n minus 1, then you multiply with the constant, with the coefficient, okay, the power, and then the constant, you just follow the derivative. Okay, all right. So that is the general power rule. Now the next rule would be, what about if I have, instead of multiplicative, or instead of something like that, you have something like this. You call it chain rule. Okay. Now chain rule is where you have a function. Okay, this is chain rule. Okay. Function is like this. You have y is a function of u. and u is a function of x. Now you want to find dy dx. So here, in order to make more sense, we use dy dx, dy du, du dx, so that because there are three variables, so that the derivative you take with respect to what variable. So if you see here, I have y as a function of u, and u is a function of x. You want to find dy dx. Okay, so you'll see here y as a function of u, and u is a function of x. So here you've got y depend on x, on u, okay, which in turn depend on x. Now what I want is dy dx. So that's why you call it chain rule. In order for you to find dy dx, I have to go what? I have to go through u. So that's why you call it chain. I have to differentiate y with respect to u, and then you differentiate u with respect to x. So that's the chain rule. So dy dx. So here now it's good that you write in terms of dy dx rather than y prime. What is it? It's dy du. You differentiate y with respect to u, and then you multiply by the derivative of u with respect to x, du dx. So you chain rule dy du, du dx. And as you can see, du and du cancel out. So you got what? I got dy dx. But you don't do that. You have to get the derivative. Okay? But the thing is, in order for you to get the chain, whether you got it right or wrong, that means at the end, you'll get dy dx. The immediate variables will cancel out. Okay? So like here, dy du, du dx. So du cancel out. So what do you have? Dy dx. But in order to do that, you have to go through the chain process. Okay? You have to find dy du, and then du dx. Okay? Any question about this? All right. So, okay. Other question? Okay, what?
No.
No. Okay, good. So, let's look at an example. Suppose we have the following. I have y equal to u to the power of negative 9.1. And u is equal to 5, equal to 15.7 x to the power of 8 plus berapa? Plus 64 x to the power of 2/3. So you see here, y is a function of u. U is a function of x. So now I want to find dy du, dy dx. So you use the chain rule. We know that what is the rule? The rule is dy dx is equal to dy du times du dx. So what I need to do here is, of course, you need to find u, du dx. Okay? So here, you can denote by u prime because du dx is u prime. Okay? And you know dy du already from there directly. So u prime or du dx is equal to what? Is equal to 15.7 times 8 x to the power of 7 plus, okay, 64 times 2/3 x to the power of, reduce the power by 1, so negative 1/3. You can multiply out lah. You can simplify this constant here. You simplify that thing. I use another color. You simplify that multiplication. Simplify that multiplication. All right, and then put in the formula. So what is dy dx? That will be equal to. I write down here. Because I probably don't have enough space. Equal to what? Equal to dy du. Now what is dy du? Negative 9.1. Okay, times u negative 10.1. Okay, that's dy du. And then you multiply by u prime or du dx, which is everything over there. Okay, 15.7 multiplied by 8. Berapa dapat?
One, two,
One.
point,
Berapa?
125.6.
125.6 x to the power of 7 plus. Okay, belakang ni. Benda ni. 64 times 2 over 3. Berapa? You can convert to decimal point. That's okay. Okay. Just give me the number lah. Berapa?
42.67.
42.67 x to the power of negative 1 over 3. So I put, take out benda tu lah. Okay, 2 over 3 x to the power of negative 1 over 3. Okay. So now, okay, last step would be what? Last step would be put in u. Okay, so that u is equal to some terms in x. So that will be equal to negative 9.1 multiplied by u. Now you put in the terms in x. So 15.7 x to the power of 8 plus 64 x to the power of 2 over 3. Okay, multiplied by here. The power now is negative 10.1. Okay, I forgot to put the power. So you have to carefully rewrite, okay, that form by and then you put in the u in terms of x and then multiplied by that term. Okay, so you write down. I don't have to write down. Okay, so that is the chain rule. Okay, the idea is that you have y as a function of u is a function of x, so you have to take derivative dy du, and then du dx, and then apply the formula. Okay, all right. So that will do it for today. Okay. So that will be the end of chapter 9, not end of chapter 9, end of chapter 9, the rules. Okay, we have covered all the rules, 9.4, 9.5, 9.6, and already I give you, the idea how you will relate derivative to the slope. So that's the purpose of this chapter. And on Monday, we will look at application of the derivative. What is the application? All right, how it is applied. So anything, any question, any comment? And I give you some questions, okay? All those questions, please do, all right? It's good that you do. You can do more questions, but don't do less. I want you to do all the questions that I give you. All right, you can do more. You have to do more. You can do the extra questions available in those sections. But that is the least, you do. Don't do a few. Okay. If you feel comfortable by doing less than the number I give you, that's fine. But if you are still not comfortable, you have to practice more. All right. So you can do more questions. That will be okay. That will be better. Because in mathematics, the more you practice, the better you get. Just like playing football, okay? Even though you are good, okay? But if you don't practice on the field, you will not play well, okay? Even Muhammad Salah, Okay, he has to practice. If you have a good practice on the field, you play well, you play better. So practice is good. It's good way to get better understanding. Okay, all right. So I think I will stop here, and I will see you again next week. Have a nice weekend. Okay, have a nice weekend, and have a nice time doing the question. Okay, do the question. Anything you can raise up in the WhatsApp group. Okay, all right. So I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam, sir. Thank you, sir.
Thank you, sir.
Have a nice
Thank you,
weekend.
sir.
Thank you, sir.
Thank you, sir.